Today, let's dive into one of the most significant processes in nuclear technology: uranium enrichment. You might have heard about it in the news, but what exactly is it and why is it so important? At its core, uranium enrichment is a fascinating process that increases the concentration of uranium-235 relative to uranium-238 in natural uranium ore. Now you might be wondering, why do we need to do this? Well, it all comes down to one crucial fact. U-235 is the fissile isotope, the superstar that can sustain a nuclear chain reaction. Think of it like this. In natural uranium, U-235 is like finding a needle in a haystack. It makes up only about 0.7% of natural uranium, while U-238 accounts for about 99.3%. But here's the thing. U-235 is the one we really need for both nuclear power plants and, yes, nuclear weapons. The process is incredibly complex and has evolved significantly over the years. Imagine trying to separate two nearly identical twins. That's essentially what we're doing with uranium isotopes. The most common method today uses centrifuges, which spin at mind-boggling speeds to separate these isotopes based on their slight weight difference. Let's break down why this matters. For peaceful purposes like nuclear power plants, we typically need uranium enriched to about 3 to 5%. But for nuclear weapons, that requires much higher enrichment levels, usually above 90%. This is why uranium enrichment is such a sensitive topic in international relations, and why it's closely monitored by international organizations. And here's something fascinating. The technology has come a long way since its inception during the Manhattan Project. Modern enrichment facilities use thousands of centrifuges connected in cascades, working together like a well-orchestrated symphony to achieve the desired enrichment levels. The environmental and safety considerations are also crucial. Enrichment facilities must follow strict safety protocols and are subject to rigorous international inspections to ensure compliance with nuclear non-proliferation treaties. So next time you hear about uranium enrichment in the news, you'll understand that it's not just about the process. It's about the delicate balance between peaceful nuclear technology and international security. It's a testament to human ingenuity, but also a reminder of our responsibility to use this technology wisely. What we've covered today is just the tip of the iceberg, but it gives you a solid foundation for understanding this crucial aspect of nuclear technology. Remember, knowledge of these processes helps us better understand the complex world of nuclear science and its implications for our future. Let's talk about one of humanity's most terrifying creations, the nuclear bomb, a topic that's both fascinating and frightening, especially given today's global tensions. Imagine this: a blinding flash brighter than 1,000 suns. In just a fraction of a second, a nuclear detonation unleashes unimaginable destruction. The immediate blast creates a fireball reaching temperatures hotter than the surface of the sun, instantly vaporizing everything within its core radius. This is followed by a devastating shockwave that levels buildings for miles around. But that's just the beginning. The thermal radiation causes severe burns to anyone exposed, and the initial nuclear radiation releases deadly doses of gamma and neutron radiation. Then comes the haunting mushroom cloud, lifting radioactive debris high into the atmosphere. Speaking of nuclear capabilities, currently 9 countries possess these weapons. The United States and Russia lead with the largest arsenals, followed by China, France, and the United Kingdom. India, Pakistan, North Korea, and presumably Israel also maintain nuclear weapons programs. Each of these countries has worked to enrich uranium or plutonium for their weapons programs, with varying levels of sophistication. But perhaps the most long-lasting and disturbing impact is on our environment. A nuclear explosion creates a devastating phenomenon called nuclear winter. The massive amounts of smoke and soot thrown into the atmosphere block sunlight, potentially lowering global temperatures for years. The radiation contaminates soil and water sources, making areas uninhabitable for decades or even centuries. The environmental effects ripple through the entire ecosystem. Plants can't grow in contaminated soil. Animals die or suffer mutations, and the food chain is disrupted at every level. Radioactive particles can travel thousands of miles through wind patterns, affecting regions far from the blast site. What's particularly chilling is that these weapons continue to become more sophisticated. Modern thermonuclear weapons are hundreds of times more powerful than the bombs dropped on Hiroshima and Nagasaki. A single modern weapon could devastate an entire metropolitan area and leave lasting environmental damage for generations. This is why nuclear disarmament remains such a crucial global issue. The consequences of nuclear warfare aren't just immediate, they're generational. affecting our children's children through environmental damage, genetic effects, and the reshaping of entire ecosystems. We must remember that these weapons aren't just numbers in an arsenal or political bargaining chips. They represent a very real threat to our planet's future, our environment, and the very survival of human civilization as we know it. The effects of a nuclear explosion aren't just measured in blast radius or casualty numbers. They're measured in centuries of environmental impact and human suffering.